Hello, good afternoon, everyone. Okay, so my voice is audible. Okay, so students are still coming. So, anyone have any query regarding the morning session that we had? We went through that numerical where we wanted to calculate the overall if collection efficiency of the cyclone separator. Any query anyone have? So, Shivani Rawat.
Yes, sir.
Can you tell me like what would be if the pressure drop in the cyclone separator is larger, is increasing, then uh, will the operational cost will increase or decrease? If the pressure drop is increasing in the cyclone separator, will the operational cost will increase or decrease?
Sir, I don't know.
You didn't you attended morning class?
No, sir.
Okay, who wants to respond?
So increase, sir.
Okay, let others, let Shubham, let other give a chance. Uh, so who wants else to respond? Sumit Sagar.
So join late in the morning class.
Increase,
So,
sir.
so it will increase the operational cost. Okay. So, but what will happen like when we are increasing the pressure loss? Are we what are we trying to why this pressure loss is increasing? Are we trying to increase the efficiency of the separator or decreasing? Let me ask uh, one by one. Rahul Sharma. Rahul.
Sir, can you repeat this?
Okay, so like I mean to ask, like if I'm increasing, if the pressure drop is increasing in the cyclone separator, then what is the main reason behind that pressure drop increase? Are we trying to uh, initially increase the efficiency of a cyclone separator, or decreasing, or we are trying to decrease the efficiency or removal efficiency of cyclone separator? As a result, the pressure drop is increasing. Did you got the question?
I, I think by uh, decreasing pressure drop, by increasing pressure drop, we are uh, increasing efficiency.
By increasing pressure drop, we are trying to increase efficiency, or it is other way, or there is like pressure drop is a effect or is a cause to increase the efficiency? Means
In
efficiency.
cost to increase the efficiency, when we drop the pressure, uh, we have high cost to operate. That's
So
why increase the cost.
what operational cost has to do with the efficiency of the separator? how operational cost is going to affect the efficiency. Operational cost means the cost incurred in order to run that instrument. So how there is no any relation with a direct relation with operational cost and efficiency, and you are trying to say that
Yes, 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 sir.
and you are saying alternatively that pressure
Yes,
drop
yes, yes.
will decrease. Who wants to give the answer? Let me ask other. So you are not there, or you were there in the morning, or in the last couple of classes in particulate removal. I am talking about this thing. So Bisal Mandal,
Yes,
Bisal
sir.
Mandal.
Yes, sir.
So can you answer that question
Sir, I
that
was
I
not
am?
in the morning class.
Why? So is that a response of yours, that you were there, so you are not going to answer? So that you are going to write in the exam that I was
No,
not
sir.
present.
Actually, I've not read right now. So we'll answer it by tomorrow, sir.
Okay. So let me ask this. This type of answers are not fitting to young faculties, because all these things, young faculty are coming from that pathway only. This answer may fit and be ease with the senior faculties. They can accept that. Ramasankar Kumar. Ramasankar Kumar. He has left the meeting. People are trying to be smart. Like, I'm asking question and he is leaving the classroom, so that I can get confused. But they don't know that this one-to-one interaction is what I am trying to do is going to carry a significant weightage in the final marks. Pratik Gedam. Pratik Gedam. Pratik.
Hello.
Yes,
Yes,
Ramasankar.
sir.
Yeah. Okay, let me ask Pratik. So, can you answer the question that I have asked?
Sir, actually, I'm not present in the morning class, sir, so that's why, sir.
What you were doing in the morning time?
Sir,
Ramasankar Kumar, can you answer that question?
Sorry, sir. There was network issue. That's why I cannot hear your question.
So, were you present in the morning or not?
No, sir.
No present. So, but I see 32 people strength was there in the morning, and now people are saying I was not present.
I was
So,
absent, sir. I did not mark present.
okay, all these things are going to create negative impression for yourself only. So, whosoever student is trying to trick me, because I have taken the snapshot. So, Deepak Kumar. Okay, can you answer like what I have asked? Like, if the pressure drop is increasing, so it is as a consequence of increasing efficiency, uh, or it has no relationship with the increasing efficiency. Hmm. Hmm. Right. Right. I don't include direct relations, but it is just to get a rationale why it will increase, because pressure drop is related to the velocity uh, to the power square to the power 2, and on the other side, if you want to increase the efficiency of then since its centrifugal force is the main force, which is again related to the velocity square. So, so this is a that I said in the morning. It's a it is a trade-off between whether the industry which is implying the cyclone separator, do they want to increase the efficiency uh, at the cost of increasing pressure drop, which they will compensate by. So how this pressure drop will be compensated? Let me ask Falak. Falak, Falak.
Yes, sir. Yes, sir.
So how this pressure drop will be compensated?
Sir, actually, from the past 1 week, we could not concentrate to the classes because being shifted to the hostel, so I could not, sir, revise much.
So were you present in the morning or not?
Yes, sir, I was present, but here in the hostel, the net is also not very good and LAN be connect, sir.
Okay. Okay. So, Soham, can you answer that?
So the operation cost increases due to your fan to increase the pressure, sir.
Right.
Electrical
To
compensation.
compensate, yeah, because there is a negative pressure is developing. Negative pressure, rather, the flow, the discharge rate inside the chamber gets decreased due to the pressure loss get in the exit path. So, in order to bring the particles to that exit part, we need to provide a suction pump or fan, kind of arrangement, so which will require power. Okay. So coming to this, now we are moving to a different another control option, which is your electrostatic precipitator. So is my screen visible? Can anyone confirm?
So
Okay.
it's visible.
Okay. So we talked about so far two aspects. Now coming forward to electrostatic precipitator. So again, we are talking in the sense that centrifugal force has centrifugal separator has higher force compared to gravity settler. That is why centrifugal separators are able to remove the now but we know that we can't go to more finer size because it will require significant pressure drop and operational cost will get higher. So then there is another technique called electrostatic precipitator, which is basically driven by the electrical charge, uh, uh, electrical force that is induced on the particle. So in this, what happens usually? So what happens that we have a kind of a chamber where we have this one discharge electrode and one collection electrode, or you can say one cathode and one anode. Okay, so one cathode and one anode is there. So basically, this particles you are seeing, the particulate leaden gas, which comprises of particles, solid particles that we want to remove. So before the entry, they are not that charged. So what is done in this process, that the ionization is the first step. Like the particles, when the gases stream into this chamber, then the cathode charge or anode, you can like if there is a cathode uh, electrode which is ionizing the charge, so then the collectors will be of anode. And if there is a anode is there which is primarily ionizing the particle, then the collector will be cathode. So opposite, and because of this electrostatic precipitator, because of the difference in between plus and minus, that is set up. So what happens in this, the particles are enter into this inlet, which are in the gaseous stream. So the discharge electrode, basically what it does, it so consider this red as a solid one particle. So this discharge electrodes creates an charge on that particle. So initially it was neutralized, but now it passes through the discharge electrode. It creates a charge on that. So suppose I'm considering discharge electrode to be positive, so it creates a uh, positive charge on the particle. So here what happens, the charge is created by the dissociation of molecules, the gaseous molecules and particulate molecules, they get dissociate in that form. So like if say iron dust is there, so or calcium dust is there in the cement factory. So calcium dust, it is Ca. So what happens when this discharge electrode is passed through, then calcium particles develop ion form Ca2 plus. Now they are charged. So since they are positively charged, so what happened then? This particles, this positively charged particles will get attracted to the negative charge walls. So these walls are of that opposite charge. So if I here Ca2 plus is created, so this walls are of negative charge. So since it's negative charge and its particles are positively charged, and we know different charge objects meet with each other, so there will be a potential difference between the particle, and then they will uh, flow through the, or they will go through the collection wall which is negatively charged. So once these particles come across this gets into this wall, so there what happens, so was negatively charged and particle was positively charged, so they get neutralized in that form. So again, so now at the collection point in the wall, the calcium particle, calcium plus, has now got stabilized or neutralized. So it will be like a solid particle Ca, calcium. Then from here, this wall, the particles are being uh, being pushed downward, or they flow downward. They are collected downwards in the hopper system, and then they are removed. So these steps are that follow. Like first step, the particles will be ionized, and due to the ionize, this particle will drift towards the negatively charged wall, because they are electrode, but they are negatively charged, and they are acting as a wall. So the negative positively charged particle will get attracted towards the negative electrode, and there they will neutralize, and then they will be dislodged, like here they are stick to this wall. So what happened, like once they are stick, so you can either go with wet process, or they are stick. So we know that anything is stick, so then vibration, this walls are vibrated or set, so that the particles are dislodged, and then they are collected and downward there is a hopper, so where they are collected, or this particle which are collected, they can be further used for reuse or for extraction purpose. So basically, if you see, the phenomena is like this. Again, the same thing is described this. So waste gas containing a smoke particle is fitted into the so these particles are getting charged, and they are, and they so see here, this is negatively charged metal grid which is ionizing the particles, and since it is a negatively charged ionization is happening, so the plate is positively charged, because it will create negative charge particles, and this negatively charged particles will deflect towards the positively charged wall. So that is how they are collected. Okay. So in this, So this phenomena is more suitable for finer particles because here you are charging the particles, and so because of electrostatic charge, they are being removed from the gaseous stream. So these particles, this gas will flow, and the relatively clean gas will come from the top. So these electrostatic precipitators are used in different industries. It can be from cement kiln industries where cement dust is being produced, and then uh, cement particles, like generally those are calcium particles or silica particles. Those are removed. Like it can be in metal industries or lead industries, like that. So where we want to remove any, because metals are basically your particulates. Okay, so that is why you see more or more metal industries will have this electrostatic precipitators, because metals are usually very finer in size compared to other components of aerosol. And these metals have the tendency, like once they are brought in contact of ionization process, then they develop charges. So metal industry, different kind of metal industries, you will find that electrostatic precipitators are more largely being used. Okay, so and in this particle can be dry dust or droplets. So this is advantage. So it can be like this electrostatic precipitators are used in combination with scrubber, like that. So, and these are generally, this electrostatic precipitator is a final step process. It is not used as a preliminary cleaning process. So before this, it may be like you have a gravity settler or cyclone separator in order to remove the coarser particle and allow the finer particle to pass through this electrostatic chamber, and you remove the fine particles. And one thing, like when this gas, polluted gas passing through, so this electrostatic charge and force are only induced on the particle, not on the gas. So gas goes in and comes out, but the So the advantage of this electrostatic precipitator is that the removal efficiency is very, very high, 98, 99%, and even for these particles. So far we have talked about like gravity settler, then centrifugal separator, and then electrostatic precipitator. So electrostatic precipitator is more efficient for smaller particles, down to the micrometers size particles, below 1 micrometer size particles, while those other previous two control options are for coarser particles. And this can handle large gas flow rates. There is a low pressure drop. So here, since we don't have this centrifugal force like kind of thing, so this advantage is that large gas flow rate means you can increase the velocity, and there will be there is a low pressure drop, because this on a concept of centrifugal force, where you need there is a dependence of velocity. And dry or wet collection, it means and once they are attached to this uh, collector plate, then either they can be shaken, vibrate, so that the dust can be collected, or either water can be sprinkled on this along the surface of this collector. So the removal of removal of the solid particulates can also happen. So both the way, dry both way can be applied in order to remove the or dislodge the particles from the collector plate. And this is very this electrostatic precipitator is functional over different temperature range, like it like and that is why it is used more preferably in different industries, because there is a least dependence of temperature on its process. So so this temperature range, like when the exhaust or the exit outlet of any industry, the gaseous stream are usually hot. So this electrostatic precipitator can be implemented there, and it involves low operating costs because there is no kind of pressure drop is not there. Pressure drop is very limited. That is why you have a low operating cost and can handle heavy dust load because it is very efficient and it is working with respect to the electrostatic charge, so it can handle significant particulate concentration and it has longer duration. However, the disadvantage is the initial installing cost is higher. That is why the capital cost is very higher when this installation process goes on. And we have said that the sources of collection acts only on the particles, not on the gas. So this electrostatic precipitator is not gonna do anything for. Okay, and it requires much space. So usually this setup is very big in size. So so for small scale industries it is not used, but for larger scale industries it will be used and doesn't work on all particles. So that is why it is more suited for fine size particles like zero point 0.3, zero point 0.4, down the 1 micrometer size range to 0.3 micrometer size range. So that is why before this step, often gravity settler or cyclone separators are used in combination so that those two processes can remove the coarser particles. Okay, and first, and another important characteristic is like it is dependent on particle resistivity. If particle resistivity means if particle is is very hard to uh, if particle resistivity is higher, then it will not develop charge. So it will not get, the particle will not get charged. So it depends upon the particle characteristics, which should have resistivity not too low, not too higher. The higher means this particles will not develop charge, but if the resistivity is too low, so all the particle will get charged up quickly, but they will dissipate very quickly and they will be not able to reach collector plate. They will quickly ionize and then they will the ionization will dissipate very quickly. So that is why the particle resistivity is very important criteria for effective removal of the particle in the electrostatic precipitate. Okay, so based on this, this Deuce equation is used, Deuce-Anderson equation, in order to control, in order to calculate the fractional collection efficiency, which is equal to minus e to the power minus WA, where this fractional collection efficiency, this N is your fractional collection efficiency, where W is your terminal drift velocity. So basically this drift velocity means, this is basically a horizontal velocity, means once this particle is charged, so it will now drift towards the collector plate. So this is called terminal drift velocity. Okay, once the particle is charged, as gas is flowing and the particle is charged, so the horizontal velocity with which it moves towards the collector plate, that is called terminal drift velocity. And A is your total collection area. This is your total collection area of your collector plate. Okay, and Q is your volumetric gas flow rate. So as I said, terminal velocity of particles as they approach the collection plate under the influence of electric field. So this particular equation is developed based on multiple assumptions. So some of the assumptions are that gases and particles move at constant velocity in x direction. So whatever gas, this is the, say this is the initial x direction movement of gas in which particles are also flowing in. So gases and particles move at constant velocity in x direction towards the collection plate with no longitudinal mixing. and then particles are uniformly distributed in y and z direction. So say this particle, this gas is coming in the inlet chamber, and particles are there. So whatever the this terminal velocity of particle will be there, it will be uniform across the entire chamber. It will not change with space and time. So if a particle is here, it will also have the same drift velocity. Okay. And the retrainment is negligible. Retrainment means we whatever particle is accumulated on this collector plate, it is not uh, re it is not retraining into the gaseous flow, meaning it is not getting dispatched from this collector plate and coming back to the main flow stream. So once the particle is stick, it remains stick until the process of dislodging happens. And this equation is again derived, like every time we are deriving, we are talking in the sense that particle is spherical in nature. Okay, so that is why whenever volume is calculated, you go with 4 by 3 pi r cube. So So based on this, so we have talked about multiple. Uh, so we are. So if you can see, this is a election efficiency. This is a different different control options for particulates, and the size range is mentioned in the x-axis. So if you can see settling chamber that we discussed, rates from 10 micrometer onwards to uh, 10,000 micrometer onwards. So this is basically for coarser particles, bigger particles, while the size separator ranges from 1 to 100 micrometer. And the highest efficient this electrostatic precipitator can remove particles from 0.01 till 10 micrometer. So this is basically whenever a fine particle is being asked, so it is electrostatic precipitator and fabric filter. This we will talk. So these two are more dominant for small size particles, fine particles, and then the this also we will talk. So, and basically for coarser particles, cyclone and settling chamber are preferred for the removal of particles. So so this two fabric filter and weight scrubber. So although weight scrubber we discuss in the gaseous pollutant, so but we'll again go through a brief because among all this five uh, control option, this weight scrubber is advantageous in terms because it at the same time it can remove particles and also the gaseous pollutant. So anyone have any question?
Sir, what was the meaning of dashed line here?
So dash line, like it can go until this range, but depending upon the extra provision in the designing is done. So usually we are not focusing there. We whatever this broad line is there, so we keep like this is the main acceptance. So this things like it can, this weight scrubber can be effective for even further smaller particle, but for that there is additional design criteria is needed. Okay. So uh, so we will solve this numerical. So kindly take a snapshot of this question as I will move to uh, attendance sheet. So just take a snapshot, and uh, I'm also showing this equation. So you need to compute what the question says. So electrostatic precipitator with 1000 meter square of collection plate is treating a flue gas at a flow rate of 200 meter cube per second from a 200 megawatt power plant. The terminal drift velocity of particle are 11.7 centimeter per second. determine the removal efficiency of electrostatic precipitator. So can I switch to attendance sheet? Have you taken the snapshot?
Yes, sir.
Okay, and the formula is this. Formula is this. Just take the snapshot and I'm moving to attendance sheet. So nobody should reply until I ask the name of that person.
So please switch on to the question once again.
Okay. Just take the snapshot.
Then, sir.
So everyone should do, and everyone who said that I was not present in the morning, I'm going to start with them that what is their answer.
So 97%.
I have said I will ask individually the name.
Okay, sir.
So I'm taking the attendance. So just so Abhishek Kumar is absent. Aditya,
Present.
Akash,
Present.
Amit Kumar Arya, Anirudh,
Present.
Ankesh Kumar, Anurag Ranjan, Anurag, Arjun,
Present.
Vishal Mandal, Vishal Mandal,
Present.
Kumar, Safir,
Present.
Nehal, Ayal,
Yes.
okay. Pratik Rupchand, Rahul Kumar Sharma,
So
Present.
present, sir.
who said present? Pratik.
Yes, sir.
Okay.
Rahul present.
Okay. Rahul, you give the answer. You have not been giving the answer in the last two classes that I
Sir,
have asked.
97.01%.
Okay, let me take the attendance complete, then we'll get back to you. Ramasankar Kumar,
Present.
Rohit,
Yes, sir.
yes sir. Okay, -1. Sandeep Kumar,
Present.
Shivani.
Present.
So you also try to give the answer once the attendance is over.
Okay.
Shubham Singh,
Present.
Sumit Sagar, Tanu,
Present.
Vivek Kumar, Vivek Raj,
Yes.
Vikas,
Present.
Deepak Kumar,
Present.
Lalit,
Present.
Manju,
Present.
Nayan,
Yes.
Rahul, Jatav, Rosa,
Present.
Aman,
Present.
Devyani,
Present.
Palak,
Present.
Dhanaraj,
Present.
Nimesh, Okay, let me ask with the other department persons. You are four are not responding in the recent classes. So, Devyani, what is the answer? Devyani? Devyani? Falak? Falak? Falak?
Yes, sir. Yes, sir.
Why it is taking so much of time? What is the answer? Then Aman,
Yes, sir.
what is the answer?
Sir, 97.01%.
Okay. Ganaraj,
Sir, same answer, 97%.
okay. Anirudh,
Sir, 97.01%.
okay. Uh, and others who were Rahul Kumar Sharma,
Sir, it is 7.01%.
okay. Bisal Mandal,
Sir, 97.01.
okay. And Rohit Pandey,
97.01.
so have you calculated?
Yes, sir.
Can you share your screen where you have
सर कैलकुलेटर
calculated?
पे किया है.
Calculator पे किया है. Okay.
Yes, sir.
So what is the if I have to ask, so I have asked what is the ask removal efficient and what is the fractional removal for the CSP?
0.97.
Okay. Okay. So I think it is very straightforward. I don't know why it took so much time to other people in order to answer this. So, any query anyone have? Any query anyone have? So, okay, let me ask this. Sandeep Kumar.
Yes, sir.
So you also got the same answer?
Yes, sir.
Okay. So can you say why operational cost in the electrostatic precipitator is low, or will it be higher
Because
or will it be lower?
lower than a cyclone separator because the pressure drop is not too much compared to the cyclone separator.
Right, right. Hmm. So, let me ask. Vivek Raj. Vivek.
Yes, sir.
So, electrostatic precipitator is good for coarser particle. Electrostatic precipitator
Yes.
is efficient for
Yes.
coarser particle. Who said yes? Why? Coarser particle. What do you mean by coarser particle? What size that you are approximating for coarser particle? When I ask for coarser particle, then what is the size range that you are perceiving in your mind for coarser particle? Vivek Raj,
So,
what is the size of coarser particle? What is the size range that you are thinking of when I coarser particle?
uh, less than 6 particles or
Less less than 6 particle up to size. Up to what
sir, sir answer sir what we asked sir it is better for particles sir.
I'm asking what is the coarser particle definition you are considering of? Forget about the initial question. When I said coarser particle, what does coarser particle size range you are perceiving? That I'm asking. What is the size range? What is the lower limit of the particle? What is the upper limit of finer particle? In terms of aerosol, when we talk about fine particle, fine aerosol, fine particulate matter, what is the diameter around the diameter we are talking about?
1 micrometer.
You are in a fourth semester, right?
Yes.
So you are still giving like entire class thing has happened, entire 20 for 30 lectures, 25 lectures are happened, and you are still not clear about what is the definition of fine size particle or coarser particle, fine aerosol, fine particulate matter. Vivek Raj,
Yes.
is PM 2.5 fine particle or coarse particle? Is
Fine
PM
particle.
wait
Basically,
wait wait wait
from 2 point,
wait wait I am asking him. So PM 2.5 is a fine particle. Are you sure? Are you sure the PM 2.5 is a fine particle?
Fine.
Vivek Raj,
Fine.
yeah.
It's a fine particulate matter, sir.
So PM 2.5 is a fine particle. Are you sure about it?
I have some confusions.
Yes, you have some confusion. Still, you are having some confusion. Amazing. So you are working under whom? Your MTech supervisor?
Professor Alun.
Okay. So let me ask. Nayan Chand.
Yes, sir.
So PM 2.5 is a fine particle or coarse particle?
Less than 2.5 is a fine particle. Its category greater than means greater than or equals to 2.5 means the coarse particle.
Yes. It is a great. It is a surprising to see Vivek Raj. Like, I'm very surprised that you just entire like 2 years going down. You have done air quality, atmospheric chemistry in first semester, and I have spent considerable lecture. Despite this course is a air pollution control, I have given sufficient lecture, 5 to 6 lecture on air quality itself, on PM 2.5 aerosol itself. And you are saying, so how did, and I'm saying this very clearly, you are, I'm having already doubts in your quiz one. That day I had said some of you have copied with some others, and I can show the exact same copy of couple of students. you are in a stage and you are not able to define what is PM 2.5. Is it a PM fine particle or is it a coarse particle? And you are still having a confusion. These things can be answered by a class 8, class 10 student. Now this in environment, this aerosol is so much dominant topic across. These are being taught in environmental science in class 10 and 12. Okay. Yes, it is very surprising to see. Like I could have really delivered things, air pollution control, and could have just gone through describing one by one without undergoing any air pollution lectures beforehand. 5-6 lecture I have given on air pollution itself in order to uh, create an environment so that you all can follow up when air pollution control is being talked about. So Vivek Raj, what work you are you are doing for your thesis work? What work you are doing?
The wastewater treatments.
I know what tell me a specific title that I know. Wastewater you are under Professor Sir. So obviously you are doing in wastewater. So what is the title, like tentative title?
So ammonia and nitrite removal by electrochemical.
Okay. Okay. Thank you everyone. But be like this is the way I will be verifying your quiz one and your midsum and endsum. Don't be in law that whatever you have written in paper or in quiz one, quiz two, or midsum. So I will be able to verify by this one-to-one simple questions, and it will be all clear who has done copy, who has done not. Okay, and so tomorrow we have a class. So will it be comfortable? Like initially I said for 9 o'clock. Will it be again comfortable if I move it to 8 o'clock, like for today? Because I don't see there is any class in 8 slot also. So if anyone is there any class for anyone at 8 o'clock for tomorrow? Sandeep?
No, so no class tomorrow at 8 o'clock.
Subham?
No class, sir. It's free, sir.
Okay. Man?
Yes, sir. It is free. 8 a.m. is free.
Okay, so I'm just writing in the chat box. We will have class on 8 to 50 itself.
Sir,
Yes.
sir, I have to come to the campus, so my train is at 8 tomorrow.
Okay, Miss, you can write to me for that. Attendance is not the important thing, but you should be, you should like the way in the initial hour when I asked question, then people were saying that I have missed an attendant, so I can't answer. So for me, attendance is not a thing. Why I'm enforcing you all to be present so that this discussion, one-to-one discussion, will make you learn what is going in the class rather by going again and reading by yourself. So this will act as your catalyst in order to understand the subject. So for attendance, like attendance weightage, as such, there is no attendance weightage, but again, it will help to someone who needs who is going to be lesser than for 1 to 3 marks. Then the grade I can accommodate in that by seeing the overall attendance. And as such, directly attendance doesn't have marks. Okay, so I will write. So tomorrow in the morning, 8 to 8:50, we will have class. Okay.
Okay, sir.
Okay, thank you.